I had come across two articles. One by Valerie Faulkner, and this one by a team of teachers. This is from Karen Karp, Sarah Bush, and Barb Doherty. And I happen to know Barb Doherty, and I happen to know Valerie Faulkner, and so what they write usually is important to me. So these two articles were dealing with language and how we need to be careful as teachers what we're saying for language. So I'm going to preface this by saying we are a safe group. I'm going to ask you to talk to me today, and I'm not going to look at you and go, oh, they said that? No, that's not it. It's a safe environment because, folks, I'm guilty of a lot of these things that they're saying should be retired. We shouldn't say these things anymore. And I have personally said them to children. Okay, so when I ask you to share something, feel free to do so. It's a very safe environment. We okay with that? So if you're sharing something, I'm not going to play the got you card because I feel we're all going to fall into some of these traps because at least I have. So that's what we're up to today, and at the end of it, I have these articles that I will email to Diane, and she can send them out to you so you can look at them. You don't have to take notes. You don't have to have paper, pencils, computers, any of that, so you can munch and drink, and then I'm going to ask you to chat sometimes with me, sometimes with the shoulder partner, that kind of stuff. All right? All right, so we know we've been working on number talks, trying to get to the heart of what kids are talking about, what do they understand, what do they not understand. And we're going to continue with that, and there's this thing up here called coherence. Now, that means what they've learned before me, I should be able to build on, and the people after me should be able to use that as well. So I want to make sure my ideas are really connected, and I want to make sure I'm not giving information to my children that's going to be, oh, that rule doesn't work anymore as they advance through the grades. So that's the idea for today. So, here we go. Remember, we're all talking. The equal sign. How do you define it? How would you say that to a kid? What's equals mean?
It's balanced.
It's balanced, okay. More?
Same thing
Same
on both
sides.
sides.
Same thing as one side or the other?
Same on both sides.
Same on both sides?
Same value on both sides.
Okay.
Equivalent to the word is.
Equivalent to
instead
the
of
word
saying.
is. Okay, so if I'm looking for English, it's going to mean is. All right. Yeah? So?
Wow.
No, not so much, because that's what one do. Same value. Okay, now, if I say I have 4 teddy bears going to a picnic and 3 more teddy bears came, and then I reversed it, 3 teddy bears were at the picnic and 4 more teddy bears came, that's not the same story, even though they're ending up with 7 teddy bears at that picnic, right? So, here's the definition. I won't read to you, you can read. Is it big enough you can see? Okay, I won't read to you.
So you're gonna send us emails on these things, right?
I'm going to actually send you the articles, and it's got more discussion on there, and I
Okay.
tried to take the bullet points out because I thought we could talk about them.
It's really hard to get out of habits like that, though.
Mm-hmm.
I'm there.
You know?
Oh, wait till you get to some of these other ones, you're going to think, what have I done to my students? We'll get there. This thing about things being an attribute, this red, it made a little more sense to me. Red is an attribute. So I'm not going to say a red truck is the same as a red lollipop just because the two things are red. They're not the same. So that kind of made a little bit more sense to me. Okay, you ready to just keep falling into my traps? I got like 25 of these.
Oh, God.
Okay, so number 1, you fell, I fell, we're all good. All right, what's the difference between digits, numerals, and numbers? Is there? And if so, what is it?
Well, digits are 0 through 9, but numbers have a value connected to them where, well, so do digits are.
Isn't this murky water?
Digits are how many, like, place value numbers. So, if you have a 3-digit number, it has 110 and 1. Well, and you have decimals, but I don't remember the decimals. Yes, and then a number is, so if it was like 379, that's a number, but the digits are
It's
3,
part of that
7,
number.
and 9. part of a number. I have no idea what numerals are.
Anybody else wanna jump in?
Numerals are what?
Is it numeral, just the number written, that doesn't make sense.
I thought they were the same thing. What?
Okay,
Yeah, you're right.
you ready?
Yeah.
No, I love the talking out loud, this is fabulous.
I don't know.
Thinking hard over there.
Don't call digits numbers.
Okay.
Instead, digits are in numerals. Numerals are written symbols that represent numbers. A little murky, so I got lots of explanations here.
So digits and numerals are the same.
Digits and numerals are not the same.
Oh.
You were 50% right.
Well, because it
Michelle.
says digits and numerals.
You, a few of you said some things I
No,
really
it
liked.
doesn't say digits are numerals, it says
Digits
digits
are
are in numerals.
Okay, so let's take a look at these.
Okay.
Consider this.
She's kinda right.
73 has 2 digits.
Right.
7 and a 3. Are we okay with that?
Yeah.
Alright. 73 is a numeral that represents the number value 73.
Okay.
Can you buy into that one?
Uh-huh.
Okay? 7 is a digit. 3 is a digit within the numeral 73. So
Right.
kind of taking these things and reversing the thinking. Standard form, 73 is composed of 2 numbers, the 70 and the 3. So we have to just not call digits numbers. We need to really say what they are. And you were pretty good with those digits 0 through 9. I'm going, this could be a really not needed slide. And then you jumped in and said, but numerals, that's the number part. And both of you combined, captured it.
Make a brain.
We're better together than
One of the
separate.
twins activate.
Okay, folks, here's your next one. How do you define addition?
Supposed to use numerals.
So you don't even use the word number.
Shouldn't. Unless you say, you know, you're breaking apart standard form. Here's my number 73, what numbers are in it?
I'm wondering if our testing does that same thing though, do they call them
This is
numerals?
common core vocabulary, okay? So I'm shifting my knowledge bank just like you are.
So digits and numerals and try to take out the word number,
Unless you're talking standard form.
unless you're talking standard
And I think
form.
we're gonna really screw up our kids.
Or, expanded
Well,
form.
we're going to be on the journey with our students, getting them described well. And I'll get this to you, so you've got it for your reference over and over.
Slides too.
I can do that. I can absolutely do that. Absolutely. All right, folks, how do you define addition?
Joining together.
Joining together.
The sum of 2 numbers.
Sum of 2 numbers. Okay, there's the math doc.
The sum of a set of numbers.
Okay, I'm talking to a 6-year-old.
When
And they're gonna go the sum of 2 numbers, and they don't get it.
When you
Combining
combine,
two or
when you
more
take
parts.
2 numbers and put them together.
Okay, 2 numbers and put them together.
If it was
Well,
a
here's
six-
the
if it
3,
was a
here's the
6-year-old.
2.
Yeah.
Put it
They would
together,
think
that would
I
be
have
23.
That's why I don't teach 6-year-olds.
Okay, so here's what we need to eliminate.
Oh, well,
But not always.
Yeah, addition. Makes it bigger, not so much, because it's about
ha! I
combining.
sort of said that.
Sort of.
Alright, saying addition makes things bigger. When they get to our middle school, and we start working with integers, and it could be before that, but the Common Core is saying in there, what happens when I'm combining a negative and a negative? I'm sorry, it doesn't get bigger. So, alright. But this could be a word problem that much younger children encounter. If I combine the $8 I have with the $2 I owe you, I will end up with $6. So that keyword combine, you know, that's gonna mess up those students who just look for those keywords and they think 10 when that's not it. Alright, so don't bypass those opportunities to use the correct language. Alright, so this one should be easy. How do you define subtraction? Since we just talked about addition.
Separating.
Comparing two amounts. Because you're comparing, if you have 7 and I have 3, who has
And I think
more?
we're still
How many more
combined.
do you have?
We're kind of dancing around where I want us to go. So, we know that's not what we want to do.
Okay.
So,
Difference.
difference, what you're saying, comparing, I'm going, she's almost there, the difference. So think about integers. If I have 5 and I'm subtracting a -3, I'm not getting smaller. What about this life situation? Don't worry about that $6 you owe me for lunch. Comparing, comparative model. So it's about that range. So how do you define subtraction? It's about the difference between the numbers. And if I want to talk about my integers, it's much larger than either of those two factors I'm working with, or two numbers I'm working with. All right, now, actually solve 25 minus 18, however you want, out loud. What's my answer? 7, okay. And think about in your head. How'd you do that?
18 plus 2 is 20 plus 5, 2 plus 5 is 7.
Okay, so we did a reverse and took it together, great. Think about some standard algorithm things. Put the 25 and subtract the 18. Think standard.
Borrow, regroup.
Borrowing, regrouping.
Make a trade. Traded
I
2
just-
10s for 1 10 and
Okay. And these numbers are small enough, we just knew it was 7, right? We did. So get rid of that. And you know, there's that old thing that says, go knock on the next door neighbor and want to borrow from it. Okay, so instead, think about this language, what they want us to use instead. We don't have access to the ones we need in this form, so we need to change the form of the number. Or I could also say, I have plenty of ones, but I just can't reach them in this. I have to decompose and recompose. Yeah.
We're really gonna confuse the parents with the language.
I'm with you. I'm just telling you where we're going. Research shows that younger students don't understand that there are actually 10 ones in a 10. Language matters. If they hear we don't have enough ones, they'll believe me. I have enough ones. I just got to get them in the right form. Okay. So shift your language to always point out that the ones are available. The form of the number is the issue. The ones need to be accessed by decomposing the higher number. And we're working with composing and decomposing. That shouldn't be too bad. You know, and if you work with those bundles of sticks and straws, do our younger students still bundle sticks and straws? Well, someday in the calendar day, when you're working on, this is the 100 and whatever day of school, drop a bundle of sticks and say, oh, I don't know what day it is, help me put them back together. You know, help your kids to learn how that composing and decomposing works.
Do you use those words in kindergarten, compose and decompose? Or first
Not
grade or?
compose and decompose,
No.
we usually, we talk about different ways to make a number,
Mhm.
different ways to make 5, we can make 5 with 1 and 4, or 2 and 3, or 5 and 0.
Introduce that big vocabulary, 5-year-olds can handle it.
Yeah.
We use decompose in first grade.
Absolutely.
We decompose every day.
Absolutely. Use that language. All right, so I don't care if you do this in your head, I don't care if you do it on paper, a calculator on your cell phone's probably not what I want, but go ahead and work out 103 minus 38. Check with the neighbor, see if they got what you got. All right, we good with that? All right, now, I actually want this to happen. I want you to go to somebody else in the room. I don't care if you turn to a neighbor, if you get up and walk and find somebody else. If there's an odd number, a group of 3 is fine. I want you to tell the person exactly how they solve the problem. And I want, when you're listening, I want you to really pay attention to the words they use. And then you have to do the same thing right back to them. Let them listen to you. Okay? So, go talk or get up and go talk. Find somebody. Go move.
There you go.
Get a party of 3, doesn't matter. Jump in somewhere. Yeah, I'm not letting y'all wait.
I do one, I would
Make 5, but, yeah.
minus 40, 60, then I added back the 3,
Yeah, I was just counting out. Yeah.
Yeah, because I said 4 to 6.
It takes more time for me to think about it, yeah.
We talked about numbers though, not doing. I mean, we talk about, yeah, I mean, they should be able to read me that number, but like, when we do the number. Yeah, yeah.
Then I didn't know, and then,
Yeah.
yeah.
That's our goal, we don't all get there, but yeah, that's our plan.
I was thinking about, yeah, as they're.
We were counting up, like we went 40 to get 40, and then, yeah, 40 to 160, and yeah, you gotta get 3.
Okay, did I give you about enough time?
Yeah, that's.
Yeah? All right, you listened to what your other people described, and I wasn't looking for all the politically correct ways. I just want to know what they said, okay? What off the top of the head, what they're saying. So let's have some sharing out. What did you say or what did you hear? It doesn't matter.
Nearest 10.
Nearest 10.
Basic algorithm.
Standard algorithm. And when you did that standard algorithm, can you give me more?
Well, I borrowed from my 10.
Borrow from your 10, okay.
And I borrowed a 10 and added it to my 3, got 13, and subtracted 8 from that, and
Okay.
subtracted 3 from that.
I
Anybody
was
else?
similar to Karen, but when I saw the 0 and the 10s, I just eliminated the 1 and made the 0 and 9.
Okay.
And just went from there.
Eliminate the one, made a 0, 9. Okay, I'm with that.
We talked about how that was the part that was really came the easiest and the fastest for us, was just to do the standard algorithm.
We were trained that way. I'm
But
expecting
yeah,
that.
so that we have to start thinking about solving it in a different way. And that doesn't come as quickly and easily
For
for
us.
Any of
for our
us.
trained brains.
No, me either.
I like Chrissy's way. She didn't like dealing with the 3, so she took 3 out of both sides and made it 100 minus 35.
So just moved it down on this number
Yeah.
line. Anybody say, 8's bigger than 3? To begin with?
No.
Did you hear that from anybody?
It is.
It is, yeah. Well, you can think of your number in a vertical form,
Yeah.
103 and subtract 38. The 8's on the bottom and it is bigger than the 3, which meant you had to borrow, compensate, decompose, train, whatever it was, right? Okay, so,
So we can't use those words anymore.
That's what I said.
Oh, boy.
Great.
how many years have we all used that terminology? And now with our Common Core and our financial literacy, borrow means, shouldn't I have to pay it back? If I'm borrowing something, it's not mine, shouldn't I have to give it back exactly what it was? Just a thought. You can't take a number from a little number, that's why I said anybody talk about the 8 being bigger, I can't take 8 from 3. Well, yes I can, I'll just go negative, but I can. Instead, trading, regrouping, composing, decomposing, those are all awesome choices. Borrowing, not anymore, because it does suggest that something should be returned. But if you use trading, regrouping to indicate the actual what you're doing, I'm actually decomposing, I'm trading out of 10, and I'm going to get these individual ones. That's okay. And that's also going to help them with the place value, figuring out piece to piece. So don't set them up for things that are going to have problems when they get to the integer pieces. Our middle school teachers will appreciate that. All right, folks, let's talk about multiplying.
What's the word I wanted to say? Thank you, that's what I was listening for the word repeated, Diane.
It's an array. It's an array. Okay.
That's a
It
negative
depends,
number.
doesn't it? Depends on what I'm putting for my number set. So don't tell me that it makes things bigger, because it depends on if I'm working with whole numbers, or fractions, or decimals, or integers. If I'm working with fractions, don't think it gets bigger. So instead, there's 3 different structures. Anybody, I heard one of them.
An array, repeated addition, and one more tip. Groups.
Fundamental counting principle. And your area model, which is your arrays. Okay, fundamental counting principle, do you know what they mean by that?
No.
Okay, you're going to Subway. How many bread choices do you have? Okay, how many meat choices do you have? Okay, let's say there's 6 bread choices. I have no idea. And let's say there's 5 meat choices. 6 times 5 would be 30 combinations. That's what the fundamental counting principle is. So there's things for elementary. There's a teddy bear that you get to dress. There's an Illuminations interactive on that. And there's a teddy bear that you get to have with so many overalls and shirt combinations that teaches the fundamental counting principles down to our elementary age. So if you're looking for something, that's what that is. Discussions about things getting bigger distracts them from what we're really doing. When I'm taking 2 times 3, isn't that the same value as 6? Right. So it's really not making things bigger. This is balanced with that. 2 groups of 3 in my array in my model is going to give me a total value of 6. Alright, so I want to teach the expressions are equal to each other, not that something gets bigger. And remember, integers, fractions, and decimals enter into this and make it a really problem. If you said to kids learning their multiplication things, it makes it bigger. What about by multiplying by 0? What about by multiplying by 1? It doesn't make it bigger. So do you think that means don't make it smaller?
Yeah.
Yeah. Don't tell them it makes it smaller. Instead, got any idea what these are?
Groups of.
Breaks, yeah, breaks into groups.
Okay, so instead of repeated addition, I might have.
Repeated subtraction.
Oh, okay. And there's no such thing as an opposite of a fundamental counting principle, so don't try to rack your brain for whatever that can be. Instead, yes, repeated subtraction. That unit rate model, let's say I walked, how many miles can I make this work? I can walk 2 miles in, however many minutes, 40 minutes or whatever it is. And then break it down, so how many miles am I walking in how many minutes? And, or how many minutes does it take to walk a mile, how many quarter minutes or a quarter of an hour, whatever, to walk that mile. And then the last one is that area model again. So it's the same thing as multiplication, it has just as much a chance as making smaller as it does bigger. Alright, now, these are gonna get even uglier. The first part of the PowerPoint was all about ideas from Valerie Faulkner's article. And it was published a couple of years before the Barb Doherty crowd made theirs. And there was only 3 slides that overlapped. And I didn't bring them all to you because, the clock keeps going. So I tried to pick out the things that I thought would be most interested to our K-8 audience, because I thought that's what we're going to work with. And so these are the rules that expire. And in this one, they talk about what the rule is, what's wrong with it, and then they match it with the Common Core standard where the rule expires, where it might have worked up until now, but here's where it expires. And if we're working with that coherence, whatever I begin my students' knowledge with, it's got to last them until the end of their math learning. That's what we're dealing with. So, anybody tell them the shortcut?
Yeah.
Guilty!
I do it all the
Guilty.
time.
Okay, guess what? Well, what happens to this rule when decimals are used, such as
Well,
2 and
we've
5
got-
times 10?
You move your decimal
You move your
point
decimal
to the
point.
Ah, but the rule the kids thought was just add a 0 to the end of the number that became 2 and 50 hundredths.
Well, you still have to move your comma when you're
Okay,
dealing with
but
regular
students
numbers.
only heard the rule for the whole numbers to begin with.
Yeah.
Now the rule has expired because now it's a rule plus a step. So it expires when I'm really doing the multiplication in 5th grade. Okay, so if you're going to tell them that, you're going to have to say it's the place value that is increasing by 10. And when we move the numbers over, we're holding the place with a 0. So everybody's moving up. And then if you move it with a 0, then I think you're gonna be okay. Number 2, we got 13 of these, I put them all in, let's hope we get to them. Have you ever told them to look for keywords in a word problem?
All the time.
Me too. Me too. Guess what? Would you find altogether usually meaning to add them all up? Or what's left as what's subtracting? Perhaps, but what about this?
Oh,
The word left is in my problem, it just indicates a left pocket and a right pocket. So if the students are used to scanning the word problem, and then they found 2 numbers, most likely they would say 37 subtract 14 if they were working with the keywords. So now we have to maybe not look for keywords. Maybe now we need to look at the question. Where's the question mark asked at in the problem? What's the question asking us? And then once we have that, now we can go back and see what the clues are to help us. Keywords expires in 3rd grade. Number 3.
Together might mean multiply instead of add too, so,
Oh, yeah.
just.
I just picked out a couple, I mean, I'm playing. Am I going too fast? I'm dropping a lot on you, I know. Number 3. Yes, you can. It might be okay when they're first starting working and they're only restricted to my whole number set. That might be okay, but why tell them that if it's going to change? The coherence piece is there, and they certainly can do integer work before grade 7, but the course says that's mastery at grade 7 for the integer. So you've got kids who are subtracting who understand about that temperature goes below 0. They understand what that is. If they're in a city and they're going down to the parking garage, it's going below level. They understand those integers. So we don't want to give them ideas that expire. This one is a repeater from both of them, so we talked about it, but I wanted to make sure that you knew that both authors over a couple of time spans are hearing this rule over and over, and it's messing with kids. So it's back up there again, and it's expiring in 5th grade and in 7th grade. Same thing along with Rule 5. That's your other that's 2 of the 3 repeats. And so we talked about it earlier, but it expires 6th and 7th grade. Okay, so rule number 6, not a duplicate.
true.
Because you have fractions.
You don't always.
And you don't always.
Right.
So, consider this problem. Jane has half of a pizza, she wants to share it with her brother. Probably not gonna happen in my household, they don't share well. What portion of the whole pizza will each get? Well, it's a half divided by 2, that's not the larger number divided by the smaller. And what if Kate has 2 cookies to divide among herself and her 2 friends, total of 3 people, 2 cookies, 3 people. Okay, so those are things that are situations that really could happen earlier, so that's expiring by grade 5. Now, what's common sense? It works for multiplying and dividing, it doesn't hold true for adding and subtracting, and integer work is generally grade 7. Number 8. Distributive property, right? When would you have kids working in distributive property?
We do it in 5th grade.
5th grade? Does it happen before then?
Yeah, sure.
Sure. What's wrong with telling them that? I know it's late in the day, I'm not gonna make you. You're all looking at me like, really? This holds true only if the numbers and variables inside the parentheses are added or subtracted. Here's your examples. So, does it work here? Is 3 times the quantity of 5 plus 4 equal to 3 times 5
No.
plus 3 times 4?
No, see, I teach it, we do inside the parentheses first,
Yeah,
that's the
And
way I
then-
teach it.
okay,
Is that
But
not
if
okay
I-
either? Oh.
No, that,
me too, Megan.
that's maybe not going to be your best choice if I'm gonna start to combine my like terms, and then if I'm going to have to do my introductory algebra work. That is a true piece. So if I'm gonna go 5 plus 4 is 9, 3 times 9, 27, right?
That's exactly how I do it.
Okay, and if I go 3 times 5 is 15, plus 3 times 4 is 12, is 15 plus 12 still 27? So the value is the same on both sides, yes?
Yeah.
So it would hold true in this case. But that's not gonna work. So if I'm doing it inside the parentheses first, 9 times 4 is 36 times 2, 72. So 2 times 4, 8. 8 times 2, 16 times 9 is more than 72, right? Okay, so it doesn't work. But a lot of times when students are introduced to that distributive property, and I don't want to get away from teaching, that I do want to distribute the factor outside, because when I start with my trinomial work, I'm gonna have to know what that distributive property does. And I've got more than one term inside of it. And I may have variables inside of it where I can't just multiply inside or add inside, I may have no things. So I do wanna make sure that I know the difference, and the distributed work should be completely understood by 5th grade. Number 9.
No, we have to multiply fractions, or divide fractions.
What if I want to do my multiplying or my dividing and I want to get a final answer?
Well, if you have a common.
What if I get, 10/8? Is it okay to leave it as 10/8? Or do I want to go 1 and a fourth?
Well, and I just think about if you're trying to add or subtract fractions, okay, it might be.
Doing the
easier to leave them as
process-
the next number. Or you're meaning like the answer?
Yeah, when I'm all the way done and I'm simplifying.
I say yes.
Yes, I do too. Me too, that's just, me too.
And I say no, because it would drive me crazy having 10 over 8 as an answer.
Well,
I don't know.
So you want it as
So you
a
want
mixed
it as a
number.
mixed number.
I
So
would
you
want it
agree
as,
with us.
I agree, yeah.
See, we already know that part in
Yeah.
5th grade, so.
Okay, now, I
I see
completely
why.
get that.
I see,
So
yeah.
we're not there, it's not what I'm required to do. I don't have it in 5th grade, and I don't even know if I have it in 6th grade, but guess what?
What about
7th
you, Mark?
does.
How do
Well,
you feel about that?
If we're doing with slope, and let's say it simplifies down to 5 fours,
Uh-huh.
I tell them it's more important to leave it as 5 fours when we're looking at the graph. So that way we can go back to the graph, and we can move up and over
Right,
4,
right.
up over 4. I
Yeah,
said if
rise
you,
up and roll over.
if you go to 1 and 1/4, then it becomes a little more complicated.
Right.
Yeah.
I mean, you can
I
go 1 and
understand.
1/4 and over 1, but then they're like, where'd you get the 1 from?
Mhm.
And then some kids like decimal instead of fraction, so they would rather have their
Exactly.
answer as 1.25.
Right,
Well, 1.25 is great if we're not doing with slope.
Yep.
But if we're doing with slope, leave it as a fraction. What if it's,
Your
the
algebra
number on top's
teachers
bigger or smaller, leave it as a fraction.
will agree exactly what you said. Your algebra teachers do not want you to do that, so it depends on what your purpose is. But don't tell them this.
Yeah.
It's fine for your purposes, it's fine to take them back and forth, and I think that's a good piece to give the visual, so I know how many pieces and parts. But it's not an always.
See, but I think it's a good number sense too, to leave it as 5 fours even if you're doing slope, because then they're having to think of what one.
That's right, I want it to be left improper. I don't want them to always have to take it to mixed number form. It has its place,
if they're doing computation.
if
Basic
that's my
compu-
purpose.
Right.
So is it wrong for us to think, well, we'll let Mark sort that out in 7th grade?
That's what I was,
Okay.
Sure. Well, you know,
And didn't you
Think
guys
this
kind of, at some of those
Right.
other conversations, think, well, let the 5th grade teacher, when it expires, let them deal with it? This is a more
But
mature
think about what
student.
happens clear down here and things
But
that you have to set up for your early learners. What do they come from preschool or home knowing that you need to get into the different mindset? We gotta be consistent. What are we doing all the way through? What are the positive behavior interventions that we wanna go through? We're doing it the same in kindergarten that we're doing the same in sixth grade. These positive behaviors have to be coherent. Same with our math pieces here.
Another thing with that though is I try to teach the kids, do it the way that you're comfortable with though. If you don't understand what 5/4 means, you understand what 1 1/4 or 1.25 is, depending on, if we get in slope, I like it to be more, but if we're just doing similar type of problem, if you've got a child that just likes decimals, well then let them work with decimals. You know, not that they shouldn't understand that it's equivalent to,
And we'll work on that
Other-
familiarity as
Yeah.
time goes on.
right, but let them do it the way they're successful at it, because there's more than one way to cut it up.
This is our bugaboo word. Okay.
Well, it's too exclusive.
Can I go on?
Yeah.
I'm gonna keep getting worse with this. Okay, it's expiring in 5th and 7th grade.
Yeah, unless you're going in integers.
Depends on what your number set is, right? If I'm working in counting numbers, if I'm working in whole numbers, if I'm working in rational numbers, if I'm working in, you know, all those kind of things. So, what you need to remember is the unit. Yeah. And then, of course, our integers are our fractions. And can someone say, it depends if I'm counting backwards. Yeah, that too. Second grade already. That one expires. So that cardinality piece that our early learners are working with, don't go here.
If you have a decimal number,
Yeah,
that's
be able
where
to
they
do-
don't.
Exactly, you got it. What about those decimals? So it was 0 and 273 thousandths. Is that a longer number?
That is
Yeah.
way bigger.
Yeah. Than 0 and 6/10?
That's what my second grader would say, that is way bigger.
Sure it is. So let's not give them that. Expires 4th grade, working more with our decimals.
Oh.
Yeah, my PEMDAS.
This is the one that just made me cry. I used to draw a cute little stick figure on the board, give her curly hair, name her Aunt Sally, you know, put some old-fashioned shoes on her. Anything I could do, I thought I was doing my students a service. So please excuse my dear Aunt Sally or PEMDAS, we would know when we parentheses, exponents, multiply, divide, add, subtract. And I think I was doing my students a little bit of a service because I would explain, well, multiply and divide, and I'd get out my sign language, and I'd say, this little symbol means best friends. And I'd make them learn a little sign language for best friends. I said, multiply and divide are best friends. Doesn't matter which one goes first. Guess what? Add and subtract, same thing, best friends. So we did a little bit of that. It wasn't enough. Because, I'm so guilty of this. I mean, just years I did this. 3 issues with this rule. I think I covered that one with my little gimmick about the best friend in the sign language thing. But, you know, students still think they read that order, I have to multiply before I divide, and I have to add before I subtract.
Whatever one comes first.
Yeah, no, that's not true. That's not true for those of you who have forgotten your order of operations. Order is not as strict to this. Now, I had a little bit of trouble with this, but remember the Common Core says multiple entry points. So consider that. 3 squared minus 4 times the quantity of 2 plus 7 plus 8 divided by 4. You have options where to start. So I could just, get 9. Or I could go 9 here. Or I could say, let's just jump to the end and I could divide there and then start combining all my pieces. I have multiple entry places. This would say, thou shalt do parentheses first. Not so much. The P would suggest parentheses are first, but what about all those other forms? Parentheses starts with P, brackets doesn't. And what about when you get those radical square root symbols? Or what about when you get those ugly equations and these are great big long horizontal fraction bar? Then what? Do everything on the top, do everything on the bottom, and then start doing the simplifying. So, no more can I draw my cute little stick figure and get students to go there. We've got 5 minutes and one more. We started this whole talk with this rule. By the way, that expires in 6th grade.
Okay, so tell me, where would you tell a student to start on that problem?
Yeah.
Wherever they felt like.
I would make sure that order of operations was known as certain things happened to happen first, and I would set things up and I'd try to get my formal answer. And I would go through the mathematician's history of the ages, and I would show them probably a PEMDAS. I don't know that I'd probably get this wonderful mnemonic, but I'd say, can I do it in these stages? And I'd probably go through solving it in different stages. Do I get the same answers?
Okay,
That's probably what I would do.
but we still probably need to start with our parentheses, correct?
When I looked at that one, I did. I jumped straight to the.
Did you go to the previous?
I did. I started right with my exponents, get rid of that mess. And I don't think it matters.
Well, on that, it doesn't matter, but
That
then
was
when
just
you
one I
get
came
to
up
the
with.
rest
Right,
of
that's right.
it, you still need to go with your parentheses after that. I mean, otherwise you're gonna screw.
As long as they know parentheses includes
It's
all these
also
forms.
brackets, and that's what I let him use the PEMDAS because it's just an easy way.
It's in all your
to-
textbooks.
Right, well, it's just an easy way to think about what you need to do, but also talk to them about, now parentheses is also brackets and all, I mean, we go through that too, and you have to do it from left to right if possible, and, you know, that stuff, but it gives them something to key to.
This has been one that's just in the, I subscribe to the journals from NCTM. Are any of you NCTM members, the National Council of Teachers Mathematics? Okay, well, I am and have been for years. And in this month's issue, they have one that says, Save Aunt Sally! And it's a board game, and it's talking about this rule and to have students have that interaction with the multiply, divide, the add, subtract, and it's got cards, and it's a whole big thing. So if you are looking and you're working in integer work, and who's my other sixth grade teacher in here? Okay, if you're looking that you want that, I can share that with you. It just came out in this month's edition. When we started this talk with equals. That's the one that keeps coming back and back. An equal sign should not mean do something. It should not mean go find an answer, should not mean you've got something to write down. It is a relationship. And that's clear down in first grade. So folks, words matter. And as you're doing these number talks and you're building number sense and you're listening to students' explanations, when you recapture their thoughts, we need to guide their thinking. We're not borrowing anything. We are trading, we are regrouping, we are composing, decomposing. We are not taking rules that are going to expire and harming our students. Now, I can pass this PowerPoint slide on, and I can pass on the actual copies of the articles, and you can have them electronically, and I'll just give them to Diane, and she can pass them through to you. Is that all right?
My thing is, and I'm not trying to be a really devil's advocate or you know,
A naysayer.
Debbie Downer. Yeah, but, okay, in 10 years, are these terms going to be different again? I mean, are we gonna come back around to using borrowing and I just think that.
What comes around goes around?
Yeah.
That made me think too of how we teach kids in reading that words have multiple meanings. So considering the context, we have to figure out what those words mean, what's wrong with that in math. You know what I mean? I thought about that when we talked about borrowing.
There are things that are not going to change. Our progression of learning, whether we call it the Iowa Core or whether we come up with some other buzzword in the future. There are things that don't change. Our numbers aren't going to change. Integers are going to arrive. Fractions are going to arrive. Some of these are common sense, and as long as we don't harm children with our language, that's what we want to think about. It will probably take me my whole lifetime to eradicate my habits. You know, I got many years of teaching these in my repertoire, and my toolbox is full of rusty tools. I need to clean them up, and that's what this is trying to get us to be aware of. And since it's coming in more and more of our reading, and since now they have 8 new mathematical teaching practices, you know, we've got the standards of mathematical practice for what students should be doing. Guess what? They've developed 8 for us. Vocabulary and discourse is part of it. This isn't going to go away. Thanks for your time.
So Diane, you always make me think, what about those 8, can we have those 8
agenda to do that, cause I could just give them to you and they wouldn't understand.
Okay,
I mean,
maybe that would be something,
productive struggle and all these love music.
okay.
But yeah, I can quickly show you, I think I have a, do we have a?
See you next week, everyone.
Yeah, if you wanna, we don't, but just so you know, I'm not telling you a story, here's what they are. This is what we're coming up to.
Let's go.
That's the next one.
There's a book I highlighted, pictures about principles of development. It's a new publication, and it's talking about 6 elements of development. And this is the